In this example, we want to solve the first order linear equation y prime plus 2y equals cosine of t with initial condition y of 0 equals 3. So we see based on the formulation of this problem that this is in fact a first order linear equation. I have the standard y prime plus 2y on the left side and a function of t on the right. This is already in standard form, which is great. So our first step is to find the integrating factor, which is going to be e to the antiderivative of p of t, which is the coefficient of y. In this case, p of t is the constant 2, so the antiderivative there is 2t, which means our integrating factor here is e to the 2t. We can then multiply both sides of this equation by e to the 2t, giving us e to the 2t y prime plus 2e to the 2t y equals e to the 2t times cosine of t. We can recognize that this left-hand side here is the derivative of e to the 2t times y as the product rule. And then we have to integrate both sides. If we integrate both sides here, we end up with e to the 2t y on the left, and the right is the integral of e to the 2t times cosine of t dt. And how does that integral work out? Well, that's a product of two functions, so your first thought should be integration by parts. And if you think back to beginning of Calc 2, we saw these problems before. This is one of those circular ones. We have to integrate by parts twice to then get back to the original integral in the first place to get your answer. So as an aside here, we'll work out this integral. So for this, I'm going to pick u to be e to the 2t, then du is 2e to the 2t dt. V is then going to be, well, sine of t, because my dv is cosine of t dt, which means that this integral is the same thing as e to the 2t times sine of t minus the integral of 2e to the 2t sine of t dt, which is a good first step, but this here requires another integration by parts. So for that second one, I'm going to take the 2 out front, and I'm going to set my u again to be e to the 2t. You have to pick the same one here, otherwise you'll undo your previous work. So my du is again 2e to the 2t dt. My dv is sine of t dt, so v is negative cosine of t. That giving that the next step here gives me an e to the 2t sine of t from that first part. I'll have a minus uv, which is negative e to the 2t cosine of t, minus the integral of v du, so negative cosine of t times 2e to the 2t dt, and I'm missing a 2 out front of this entire integral from that 2 I factored out in the first place. So now I can move some signs around, simplify some things out. These two will cancel, and I will get as an expression here e to the 2t sine of t plus a 2e to the 2t cosine of t, because that minus sign will cancel with the one outside, and then minus 4 integral of e to the 2t cosine of t dt. But now remember, this whole thing equaled the integral of e to the 2t cosine of t dt, so I can rearrange this. And when I do that, I will get that 5 by adding this 4 to the other side. Integral of e to the 2t cosine of t dt equals e to the 2t sine of t plus 2e to the 2t cosine of t. And I can divide both sides by 5 to get this actual integral as 1/5 e to the 2t sine of t plus 2/5 e to the 2t cosine of t plus c. So with that all worked out, now I can go back to the original problem, which was this up here. I have that e to the 2ty was supposed to equal that integral. Now that I have that integral, I can then write what that tells me. It tells me that e to the 2ty equals 1/5 e to the 2t sine of t plus 2/5 e to the 2t cosine of t plus c, or dividing through by e to the 2t, y equals 1/5 sine of t plus 2/5 cosine of t plus c e to the minus 2t. that's my general solution. And then the last part we have to do is find the value of c for the initial value problem. We were told we wanted y of 0 to equal 3, so I can just plug in 0 and get that 3 should equal 1/5 times sine of 0, which is 0, plus 2/5 cosine of 0, which is 1, and c e to the minus 2t, e to the minus 2 times 0 is e to the 0, which is also 1, meaning I need 3 equals 2/5 plus c, or in this case, c equals 13 over 5, because that left side is 15 over 5. Thus, my final answer for this initial value problem is y is 1/5 sine of t plus 2/5 cosine of t plus 13 over 5 times e to the minus 2t. That's how you work out this initial value problem for a first order linear equation with a right-hand side that in this case required double integration by parts, but besides computing that integral, the rest of the problem follows the same algorithm as it always does. Integrating factor, integrate both sides, get to a general solution, and then figure out the constant c to give you the solution to the problem that you want to solve these sorts of equations.